here we have a question where we have to solve the differential equation and find the solution of the equation. Now, to solve the differential equation, we have many methods. So we have seen a method of variable separation in the lower standards, and there are multiple methods to solve the differential equation. Now question arises that which method we must apply to get the answer. So let's start. So here you can see that the given equation is in the form m dx plus n dy equal to 0. So we have seen the exact differential equation where the equation is in the form m dx plus n dy equal to 0. So I'll show you. So here the form of exact differential equation is given. So according to this, if the equation is in form m dx plus n dy equal to 0 and if the value of dou m by dou y is equal to dou n by dou x, then we say the equation is exact, and then we use this formula to get the solution of differential equation. So now here first of all we need to check whether dou m by dou y is equal to dou n by dou x or not. So let's start. So here I'll say comparing with m dx plus n dy equal to 0. So here we can say that therefore the value of m is the coefficient of dx, that is y into xy plus e raised to x, and the value of n is minus e raised to x. Now let's take the value of dou m by dou y and dou n by dou x. So dou m by dou y is nothing but partial differentiation of m with respect to y by treating or by keeping x as constant. So here if I see the two terms, then in both the terms we have y. So here I am going to use the rule of product, that is the UV rule of derivative. So first of all I'll write this y as it is. Now we'll find out the derivative of this term with respect to y. So here we'll get x. For e raised to x we'll get 0 because we are partially differentiating this term, plus xy plus e raised to x as it is, and again the derivative of this y with respect to y is 1. So here we got the value as xy plus xy, that is 2xy plus e raised to x. Now let's take the value of dou n by dou x. So here that will be minus n as it is and e raised to x. So guys, if you observe carefully, then the value of dou m by dou y is not equal to dou n by dou x, and hence we'll say that the given differential equation is not exact. So therefore since this equation is not exact, hence we cannot use the method of solution of exact differential equation. So now question is which method we must apply to get the answer. So for that we have to observe the other forms of differential equation. So guys, here we have this form which says that if the value of dou m by dou y minus dou n by dou x upon n is equal to f of x, then the integrating factor is this, and after finding the integrating factor and then multiplying the differential equation with integrating factor, we can convert that differential equation in exact. So we may check this form, that is the form number 3 or form number 4. So let's check the form number 4. So the value of dou n by dou x is minus e raised to x, whereas the value of dou m by dou y is this. So let's subtract these two values. So here I'll say therefore dou n by dou x minus dou m by dou y equal to, so when we'll subtract these two values, we'll get this minus 2xy minus e raised to x. So that will become minus 2 times xy plus e raised to x. And guys, here in the denominator we have m. So the value of m here is this value, that is y into xy plus e raised to x. So y into xy plus e raised to x. Now here you can see that we can cancel this bracket xy plus e raised to x, and then we can get the answer as minus 2 upon y, which is nothing but function of y. So in short, here we are getting the value of dou n upon dou x minus dou m by dou y upon m as function of y, which is mentioned in the property. So here you can see that if we are getting this answer as a function of y, then we say that this is the integrating factor, and then we multiply the given differential equation with integrating factor to make it exact, and then by using the solution method of exact differential equation we can get the solution of the differential equation. So guys, here let's find out the integrating factor. So I'll say by this formula, therefore the integrating factor is equal to e raised to integration of f of y, that is minus 2 by y dy. So here this minus 2 will come outside, and the integration of 1 upon y is log of y. So this will become e raised to log of y raised to minus 2 by the property of b log a equal to log a raised to b. Now here e and log will be cancelled, so we can say that integrating factor is y raised to minus 2 or 1 upon y square. So here we got the value of integrating factor as 1 upon y square. Now we'll multiply the given differential equation with the integrating factor. So guys, here we have the equation. I'll multiply this equation with the integrating factor and I'll make it exact. So here I'll say therefore multiplying so 1 upon y square into this first term will give us dx, and 1 upon y square into this second term will give us minus e raised to x upon y square dy equal to 0. So guys, now this differential equation has become exact, and we will use the method of exact differential equation to get the solution. So its solution is given by a formula. Here I'll write that its solution is given by integration of m dx by treating all the y terms constant plus integration of n dy by considering the terms which are independent of x. Is equal to c. So this is the formula. So guys, this is my new m. So here I'll say integration of x plus e raised to x upon y into dx plus in n I'll find out the terms which are independent of x. So for n I have only the single term which has x, so I do not have a term which is independent of x, hence we'll say that this term is 0. So here directly we'll get equal to c. Now integration of x with respect to x is x square upon 2 plus here we'll get e raised to x upon y equal to c. And guys, this is nothing but the solution of given differential equation. So here we got the solution by using the method of exact differential equation and by reducing the given equation to exact. Thank you.